Now I've got some fun integration. We've got an easy, medium, and hard one. You want to guess which is which? Easy, medium, hard. At least for Math 3A. So this one is going to be a straightforward u substitution. Let u equal the denominator. And then take the derivative of that. It's going to be 3x squared with respect to x. And then this has an x squared dx, but not a 3, so we need to multiply by 1/3 on both sides. And then it's ready for the u substitution. So we'd have, there's going to be a 1/3 du. I'm going to factor out the 1/3. And then the x squared dx gets replaced with 1/3 and du. And the denominator is u. And that is set up for the natural log. So the antiderivative is going to be 1/3 the natural log of u plus a constant of integration. The last thing to do is replace the u with what it's equal to, which is that x to the 3 plus 3. And technically that's supposed to be an absolute value so that you don't take natural log of a negative number. And there we go. Next, for the more challenging one, if you try u substitution, this is going to be the u. The du would be a 3. And this doesn't have, or excuse me, this has an extra x in it that the du doesn't have. So if we use u substitution and let u equal the denominator, then the derivative of that's going to be 3 dx. And so we're going to need to find out what is x equal to, and then substitute it in right there. So from this one, x is equal to, let's see, we need to add 5 and then divide by 3. So add 5 and divide by 3. And then substitute that in. And substitute, well, this one doesn't have a 3 dx, so we're going to have to multiply by 1/3 on both sides and have 1/3 du equal to the dx. And now I think we're ready. So we'd have the 1/3 can be factored out, and then in the numerator we have 2 times what x is equal to. And then there's a plus 1. The dx gets replaced with 1/3 and a du, and the denominator is a u. And now I think that if we just do some algebra, this will turn out to be a reasonable antiderivative. Let's see. So this would be 2/3 u, and then everything's going to be divided by u. So what I'm going to do is break it up into, instead of having one big fraction, I'm going to break it up into a couple of little fractions. So there's 2u over 3, but then that gets divided by u. So 2u over 3 is then divided by u. Can you see my scratch paper up there? Then the u's are going to cancel. So we're left with just a 2/3. Then distribute this, it's going to be a 10/3 plus a 1. So 10/3 plus a 1 would be 13/3. But then it gets divided by a u. So you'd have 13/3 gets divided by a u. Okay, then just integrate these two. So this one is essentially like 1 over u, or du over u. That's natural log of u. And then the constant 13/3 would just be in front. And then integrating this one with respect to u would be 2/3 u, and then plus a constant of integration. And then the last thing to do is replace the u's with 3x minus 5. So, oh, and also distribute this. So it's going to be 2/9 and then 3x minus 5 plus distribute, so it's going to be 13/9 and natural log of 3x minus 5 plus c. And finally, on to integrating cosine squared. So there's no direct trig functions whose derivative is cosine squared, not like derivative of tangent is secant squared, so we can't get away with something as easy as that. If you use a u-substitution, u is going to equal the cosine, the derivative of that is negative sine, and we have no sine in this problem. But what we can do is rewrite this one as cosine of x times cosine of x, and replace one of the cosines with something that has sine in it, and use the other one for the u. So we have the identity that sine squared plus cosine squared is equal to 1. And from that we can derive that cosine is equal to the square root of 1 minus sine squared. So we've got, I'll replace this one with that square root of 1 minus sine squared. And this cosine just stays there. Well, now that I look at it, my plan changes just slightly, because when using u-substitution, you should try to use the inside function, which is that sine in there. And so we're going to let u equal sine of x. The derivative of that is cosine of x. Making the substitution, we would get the square root of 1 minus u squared, and then du. And there's no algebra for us to be able to really simplify this, so we just have to deal with it the way that it is. And you might say, hey, isn't that the antiderivative, or isn't the antiderivative sine inverse? If only it were a fraction. 1 divided by that would be sine inverse. Can you take the square root of u squared? Nope, not with subtraction in between. What else could we do? Well, we've pretty much tried everything. The next thing to do is wait until Math 3B, and then we'll be able to do it in Math 3B. So this is one of those that we can't do yet. Next semester.